Here's example 2 with evaluating trigonometric functions with right triangles. So example 2, find the exact values of the 6 trigonometric functions of alpha. So we've been using thetas a lot. Remember we talked about alpha, beta, and gamma and theta a few videos ago. So let's use alpha here. And so just another lowercase Greek letter. So let's say we're given this right triangle here. Here's our right angle. Here's the angle alpha, and we're given the side opposite to it and the hypotenuse of the triangle. Okay. So before we do anything, what we really should do is figure out what this missing side is. So let's call it x. So remember the Pythagorean theorem tells us that x squared plus 4 squared equals 7 squared. Okay. So 7 squared is 49, and then let's subtract 4 squared from both sides. So 4 squared is 16, so we're going to subtract 16 from both sides. Okay. So 49 minus 16 is 33. So then x squared is 33, so then we take a square root of both sides. Okay. And again, just like in example 1, there's a positive and a negative root, but since x represents the length of the side of a triangle, then we're going to take only the positive root. Okay. And square root of 33 cannot be simplified anymore, so it's just 11 times 3, so that's 2 prime numbers, so we can't simplify this anymore. Okay. So now that we have this, so x equals the square root of 33. Okay. So x equals the square root of 33. Okay, so now that we have this, we can find all 6 trig functions, so let's go ahead and do that. So in the last video, we talked a little bit about rationalizing the denominator and things like that, so we're not going to talk about it here, and we're not going to do that here. We'll just answer leaving square roots in the denominator if necessary. So sine of theta equals, so from here on out, so really this is kind of the bulk of the work right here is doing the Pythagorean theorem, and the rest of it is just remembering the definitions of the trig functions and the identities, the basic fundamental identities that relate them to each other. Okay, so remember the sine of, oh sorry, not theta, but alpha. So we're using alpha here, not theta. So the sine of alpha is going to be opposite over hypotenuse. Okay, so the opposite side is 4, and the hypotenuse is 7. Okay, so we could have got that one at least without this leg, but we do need this leg for most of the other ones. So that's sine of alpha. Cosine of alpha is the adjacent side over the hypotenuse. So the adjacent side is x, which we found out was square root of 33. So the cosine of alpha is adjacent over hypotenuse, which is root 33 over 7. Okay, so that's cosine of alpha. And then tangent of alpha. So tangent of alpha, if you want, you could do sine of alpha divided by cosine of alpha, or we could just look at the triangle and see, okay, tangent is opposite over adjacent. So if this is alpha here, the opposite side is this side, and the adjacent side is this side. So the tangent of alpha is going to be 4 over root 33. Okay. And again, we're not going to bother rationalizing the denominator here, because there's just really no point in doing that. Okay, now for the other 3 trig functions, there's no point in doing that here, I should say, because it's not going to simplify it anymore. But anyway, for the other 3 trig functions, we could use the triangle and the definitions of the trig functions, or let's just totally forget about that triangle and just remember, okay, so now we want to do cosecant of alpha. Remember, cosecant is the reciprocal of the sine. Okay, so if the sine is 4 over 7, then cosecant is the reciprocal of that, which is 7 over 4. Okay. Cosine of alpha, if we take the reciprocal of that, we're going to get secant of alpha. So the secant of alpha is the reciprocal of this guy, which is going to be 7 over root 33. Okay. And then finally, the cotangent of alpha. Cotangent of alpha is going to be the reciprocal of the tangent. So if the tangent is 4 over root 33, then the cotangent is the reciprocal of that, which is the square root of 33 divided by 4. Okay. So notice, remember, again, for these last 3 trig functions here, we didn't have to use the triangle at all. We could have if we wanted to. Okay, so you remember, sine is opposite over hypotenuse, so then cosecant is going to be hypotenuse over opposite. So you could think of it like that if you want, but it's really important to know these relationships in general, that cosecant is the reciprocal of sine, okay, because even if you're not working with right triangles, those reciprocal identities are still true. Okay? So it's really important to keep those in mind. So anyway, these are the answers here for example 2. And again, just like in example 1, we're looking for exact values. So we don't want to approximate anything with the decimals. So square root of 33, leave that as square root of 33. Don't approximate with the decimal or anything like that. Okay, so that's example 2 with right triangle trig and evaluating trig functions.